Welcome, my name is Terry Soul, and this is Programming Chaos, a channel devoted to fun and interesting projects to help you hone your programming skills. For today's project, I want to start building an artificial evolutionary life simulation. So the idea is we'll have lots of creatures moving around and evolving over time. And I should say up front, this is a bit of a big project for one video, so I'm going to spread it over several. And this initial one, I'm going to be creating the environment for our creatures. And so you can see here, they're moving around a map that has a distribution of water and land and different food resources, and they're evolving over time to be better adapted for that environment. In order to program the environment, of course, we have to understand a little more how it works. And so let's take a look at that. So here I have a close-up of the environment. We have our little creatures running around. You can see there's land, there's water, and then there's food. And I'm going to have two different kinds of food. So land food, think of it as fruit, and water food, I don't know, maybe seaweed. And the creatures, in order to get enough energy to survive and reproduce, have to collect food. You'll notice that my environment is divided into a grid, so a little bit coarse-grained, and that's mostly for purposes of efficiency. One of the big things that we have to worry about in any artificial life simulation is sensing. So you might think, well, it's easy, we'll just have them be able to see their environment. Well, to model seeing, you've got to do ray tracing on millions of rays of light. And then they have to go into an eye and a visual cortex, and it gets extremely complicated and, more importantly, CPU intensive. So I'm going to take a much simpler approach for this particular A-Life simulation. And that is, my creatures have these two little sensing organs. So there's these dots out here. You can think of them as eyes if you want. Maybe a better way to think of them is like antennas that go out and touch the ground in front of the creatures. And they can sense, for example, whether they're touching water or land. But you'll notice around the food there's this little haze. You can think of that as scent. So imagine that this is, as I said, a berry, and around it there is the smell of the berries. Well, now with these sensors, the creatures can tell, is the scent stronger here or here? And then they can evolve to either turn towards or away from the stronger scent. And you might think, well, it's weird to turn away from the scent. And that's true, but evolution doesn't know any better. So one of the things we'll see is as we do random mutations, some creatures will randomly mutate to say, I'm going to turn away from food. They'll quickly starve to death and fail to reproduce. So that's how evolution works. The ones that turn away from food die off, and the ones that turn towards food get more energy and get to reproduce. But that's on the evolutionary side. In terms of our environment, what this means is when we put down a piece of food, we fill the cells around it basically with scent. And then creatures using their, like I say, if you want, you can think of it as antennas, can sense that scent and thereby hone in on the food. And this does have some analogies in the real world. Insects, for example, really do, in a sense, taste with their antennas. So when they're touching the ground, they can taste what is there, and scent and taste are very closely tied together. So not as unreasonable as it might seem to do things this way. So that's going to be the basics for sensing. Creatures can sense in front of them at two particular locations. This does limit their ability to sense the environment a whole lot. All they know is off to the front left and the front right, they can sense if there's any smell there, and they can tell whether there's water or ground there. But beyond that, they can't do much. And so this is pretty limiting. The nice thing about it is we can program it to be very, very efficient. For example, whenever we put down a piece of food, we just immediately put the scent around it, and we're done. It's just an array of where the scents are located, and then we can look up in that array, is there any smell there for the creature to detect? One of the things I'm going to leave out, which is a little disappointing, but saves a lot in terms of complexity, is the ability for the creatures to sense each other. So we could set it up so that every creature also sort of has a smell around it. But that gets much more computationally intensive because as the creatures move, you have to keep adding more and more smell, and you have to have it dissolve or dissipate behind them in some way. So for now, in this model, creatures can sense food. They know what environment there is. They're not going to be able to sense each other. If you're interested in this notion of sort of scent diffusing from the food or even diffusing from the creatures so they can smell each other, you might want to check out the previous video on reaction diffusion models. So this gives us a sense for how the environment is going to work. There's going to be land and water. Every square in our grid may contain food. It may contain a level of smell or scent. And so the way I'm going to set this up in code is I'm going to create a cell object, and then I'm going to create a map that consists of lots and lots of those cells. And to make the map, I'm going to use Processing's built-in noise functions. If you're interested in more complicated maps, again, there's a previous video on making maps using processing and noise. I'm keeping this very simple in the interest of time, but also because once you have it done, it's easy for you to expand on it the way you want. So there's the model. Let's start with the coding. So as with a lot of my projects, I'm going to be doing this in processing, which is Java with a nice environment, the processing environment to code in. You'll notice that I'm using the P3D environment. So this is actually going to be a 3D environment. My artificial life simulation is basically 2D, but 3D allows me to zoom in and move the camera around. And so really it's a 2D simulation with a 3D camera. To get started, I'm going to need to define some of the parameters of the environment. So one thing is the scale of the cells. So I'm going to say each cell in my map is 4 by 4, and that's pretty easy to adjust. Then I need the size of both the overall map in terms of pixels, because the creatures move around freely, and the map size in terms of the grid. So there, that's going to be the width and height of the map in pixels and the width and height of the grid in terms of those 4 by 4 cells. There we go. This may look a little odd because I'm just making the width of the map the same as the width of the window and the height of the map the same as the height of the window. But by putting in that 1 times factor, by changing that, I can easily make a bigger map if I want. And then the grid that I'm using for locating things like food and land and water is just going to be the width of the map divided by the scale that I'm using the cells. So the grid in this case is 1/4 as big as the overall map. One note, that should be an even divisor. So I want 4 to evenly divide into whatever I'm using for the map width and the map height, which it does in this case. Okay, so that defines the sizes that I want. And the next thing I want is to define a cell class that stores all of the data about each cell in the map. And so there's a little bit of data that needs to be stored in each of those cells. What I'm going to store for now in each cell is the altitude of the cell, and that'll determine whether it's land or water and let me shade things in nicely. And then if there's any scent from fruit, if there's any scent from nearby seaweed, and if there's any food stored in that cell. And I'm going to do that as a string, and I'll just set that string equal to either fruit or seaweed. And notice it's quite easy. If you want to add more food types, you'd add more options for the string and then more different scents. And then I need a constructor. And the constructor sets everything to sort of null values, so 0 for the amount of scent and an empty string for the type of food, and sets the altitude based on an argument that gets passed in. So the idea is I'm going to use noise to generate the map, and as I'm generating each cell using that noise, I have to tell the cell what its altitude is. And that's really all I need for the cell class. It's just data that is located in each cell in the map, but by setting it up this way, it's easy to add more data members if I want to make a more complicated environment. And now that I have that, I can create the map object. And so this is going to be my map class, and then in the main code, I'll create one map object. And what the map will store is just a two-dimensional array of cells. Then I need a constructor to construct maps. So this will create my new two-dimensional array. One thing to notice is height comes first and width comes second, because now we're dealing with a two-dimensional array, and those are always rows, which is height, followed by columns, which is width. So that creates the array of cells. And now I need to fill in each of those cells. I'm going to be using processing's noise function, which is a variation of Perlin noise, to fill in the altitudes, which will give me a nice sort of organic looking map. And so I'm going to use A for my altitude, and then we have to scale the Perlin noise. And by changing the scale, you can get more or less detail on your map. I found for this 0.01 works pretty well. And now we go through and fill in the altitude for every cell in the map. So there's the beginning. I go through every row and every column in my grid. I calculate the noise using my noise scale to get the right level of definition that I want, the right level of detail. And then noise returns a value between 0 and 1, usually focused around 0.5. What I would like is negative values to be below sea level and positive values to be above sea level, so land. And so I'm using the map function. A little confusing because I also have created this map class, but Java keeps it all straight for me. I'm using the map function to take that altitude, which ranges from 0 to 1 based on the noise function, and remap it from -1 to 1, basically taking the map and stretching it so half of it is below sea level, and now I can create my new grid objects. So there we go. I create a new cell with the given altitude. And this creates a map for me. It's not going to do me much good though unless I can display it. So pretty typical, the next thing I'm going to do, the next function I'm going to create for my class is a display function. And I'm going to want to color in my cells but with no stroke around them, so I'll do that first. And then I simply need to go through every cell, look at its altitude, and decide whether it should be colored as land or water. So here I'm going through every row and column, so I'll go through every cell and I'm going to check the altitude, and if it's less than 0, that means I'm dealing with water. And I'm going to get a little bit fancy with the coloring, so I'm using RGB scale, so no red, no green. I'm going to use maximum blue, 255, but I'm going to subtract from that the altitude times negative, I want 200 there. So the altitudes are already negative. So I'm going to multiply by -20 to make it positive, and therefore the lower or deeper the water, the more I subtract. And so deep water will look darker. And again, if you want sort of more fancy rules for making fancier maps, you can check out the video on just generating maps themselves, linked here. So there we go, and I'm doing the same thing for land, except now it's the amount of green. I should put in 0 blue there. So maximum green, and as we get to higher altitudes, we subtract from that, and so the higher altitudes will be a darker green. We have a map that we can display, and now we can come back over here and create it. So there's my map object. I'll create a new map, and we can display it. Let's see. Close my for loops, need one more closing bracket to close off my map function. Oh, yes, and the other thing I'm missing, I have a nice fill color. I didn't actually draw in any of the rectangles. So we need a rectangle to put in. There we go. So I set the colors, but I hadn't actually drawn the rectangles. The location of the rectangle is the column and row but I have to multiply by the cell scale, which is 4. So if I want to draw the rectangle for, say, column 10, I actually have to move over 40 pixels. And then the size of the rectangle is the cell scale. And now finally, there's our nice map. Two things I want to do from here. One is add food, because that's going to be part of the environment. The other thing I want to do is be able to zoom in and move around. That's the whole point in making this a 3D environment. And if I can't zoom in, I can't see the creatures up close, I can't move around, it's not nearly as interesting. So I'm going to do that piece next, the ability to zoom and move about. The other thing that's worth pointing out is my noise scale here is, again, what determines the level of detail on this map. So you see we've got some little islands and some little lakes. If you don't want those, you can make the noise scale smaller. If you want more fine-grained detail, you can make the noise scale larger. Okay, but let's deal with the ability to zoom and move around our map. For the zooming, I'm going to come back to my main code, and we need to know the location of the camera. So we need some variables for that. So how zoomed in is it, and what is the XY location as we move around the screen? So those are my 3 variables. And the XY location is pretty simple. It's the camera starts focused on the middle of the window. The zoom is much more complicated, and we don't really need to worry about it. You can look it up if you want, but this is how the zoom should start. And basically that puts the zoom at the right distance to just be looking at the window. Now we need to be able to change those, so I'm going to add a function that allows us to use inputs to change the XY position of the camera and the amount of zoom. And I'm going to use my own key input function that I'll call on every loop to check whether or not a key has been pressed. So processing has a key pressed function that is called whenever a key is pressed, but the problem with that is you can't hold a key down. It's called once when you press it. So I'm doing my own function that I'll check on every loop to see if a key is currently being held down. There we go. So this is just checking the built-in key pressed variable. If a key is pressed, then I want to look at what key it is and adjust the camera accordingly. So in particular, if a key is pressed and the key code, that should be capitalized, is the left arrow key, then I will move the camera's X position a little bit to the left. And the 5 there is arbitrary. You can play with that if you want to be able to move faster or slower. And now I just do the same thing for my right, up, and down keys. And a little bit odd, but up is -5 because of the direction of the x-axis, and down is +5. And now that we've changed the XY position of the camera, we have to reset the camera. So there is a camera function that sets where the camera is located, and I want it at this new location. So that has moved the camera on the screen to my new XY location, but we need a couple of other parameters. We need to say where the camera is facing. So you can also rotate the camera to face in different directions. I want it to be facing directly at the map. So if it's at location XY, I want it pointing directly at the XY location on the map. So there we go, it's looking straight down on the map. And then the last 3 arguments I'm not going to worry about too much, but those have to do with what is considered up and down for X, Y, and Z, and I'll just leave them as 0, 1, 0. You can look them up and play with them on your own if you want. And so now if I run this, I have to remember to click on the map to make that the active window, but I can zoom back and forth. And I'm getting some weird dragging here because I didn't put a background in my draw loop. So let's do that. There we go. And now you can see I'm immediately going off the edge of the map, which is fine. Really, the moving around is going to be most useful when I can zoom in. So let's do the zooming next. And for the zoom, I'm going to be using the mouse wheel. So processing has a built-in function that when the mouse wheel is moved, we call the mouse wheel function. When that function is called, it is given a mouse event value that it can use, and I'm going to use that to adjust how the zoom goes. And the way this works is the event is an object, and I want to get the count from that, which is basically a count of how much the wheel has turned. And generally, that's a fairly small number, so I'll multiply it by 10 and add it to the zoom. And depending on which way you move the mouse wheel, that's either a positive or a negative number. So I'm automatically increasing or decreasing the amount of zoom. And now I can simply redo my camera command from up above here, but with the new zoom value. I've changed the zoom, I've got to move the camera accordingly. There we go. Again, click on the window to make sure it's active, and now using the mouse wheel, I can zoom in and out, and using the arrow keys, I can move around. I haven't put a control in, so if you zoom too far, you basically zoom through the map. So we could put in a maximum zoom if we wanted, but I'm not going to bother with that. And if we zoom way out, we end up with a little teeny map, but again, I'm not going to put a limit on that. You can add one if you want. So there, we've got a nice map that we can zoom in and zoom out on. Now what we want to do is add some food and put scent around the food. Okay, so now I want to add food to my map. So I'm going to come back to my map class and I'll add a function to do exactly that, add food. The first thing I need to do is pick a location to try and put the food down in. So I'll pick a random location, and if there's already food there, I don't want to try and place any food there, so I'll just exit. So there we go. If the food string is not an empty string, just return. Otherwise, we can put some food there. And the type of food depends on the altitude. So if the altitude at this location is less than 0, I'll put down seaweed. And if the location is greater than 0, I'll put down fruit. And again, this makes it pretty easy. You could put different altitude levels with different food if you wanted more types of food. And now that I've added the food, I should also display it. So I'm going to come down and change my display function so it displays the food for me. So I'm already going through each location in the grid and filling in the rectangle with the appropriate color. Now what I want to do is add food. So if there's a piece of fruit at this location in the map, I'm going to fill with bright red, and I'm just going to put a circle there. The key is I go to the column times the cell scale, so I have to convert from grid to pixels, so I'm multiplying by the cell scale, and then I want it in the middle of the cell, so I have to add another half of that scale. And I will do the same thing for the Y value, which is based on the row. And then I'm going to make it as big as the cell. So that will be the size of my circle, is the size of the cells. So that is for fruit, put in a double equals, and then I'm just going to copy that over and do the same thing with a different color for the seaweed. And I'll make the seaweed green. Now I can display the food, I can add the food, but there's none in the map yet. So when I first create my map, I'm going to add a bunch of food. So that will add 100 food initially, and that's a very arbitrary number, but it'll at least show how this works. And there's my map with food on it. I can zoom in and we can see, sure enough, we get fruit on land and seaweed in the oceans. Because the creatures are going to be eating food over time, I'm also going to want to add some food at each loop. And so I'll just do that every time we go through the draw loop. I'll also add a piece of food. So to the map object, I'll add a piece of food. There we go. And so you'll notice now that food keeps getting added. Every loop, we add another piece of food. This may or may not be too fast. So in creating an artificial life model, one of the tricky things to balance is how much of a population size do you want? And in order to get that, you have to decide how fast does food replicate. And notice this is a pretty boring version of food. The food doesn't evolve, it doesn't move around, there aren't trees that grow over time and drop fruit, it's just randomly thrown in food. But it's a good starting simple model, and if you want to make it more complicated, go for it. So the last thing we need to do is add the scent around the food so that the creatures will be able to sense where it is. So let's do that next. So to add scent, I also have to keep in mind that when a piece of food gets eaten, I have to remove the scent. So I'm actually going to create a change scent function, and I tell it the location that the food is located at, and then it either adds or removes the scent from there as necessary. So here's how that will work. I'll give it the row and the column, and then the flag will basically be whether I want to add or remove scent from that location. And I'll need to know how much scent, so I'll create a float for the amount of scent. And I have the food location that's given by row and column, but I need to move over and up to start placing the scent in a grid around it based on some scent range, and that's just a variable that I'm going to need to create. So for example, that could be 5. So in a grid, we go over in each direction 5, and that's sort of how far the scent dissipates from where the food is located. So there, that's going to go in a grid around the location of the food. And now I have to decide how much scent should be there. That's my scent variable. So here's how I'm going to do it, and there are other ways, but this seems to work well. I'm going to start with the scent range, and then I'm going to divide that by the distance from where the food is located, row, minus the current cell I'm dealing with, R. So here's where the food is, here's the current cell that I'm looking at. I'm calculating how far apart we are by taking the difference and squaring it, and then adding that to the difference squared for the column. So basically, I'm calculating the distance from the food to that cell and dividing that into the scent range. So as we get further and further away from the food, the amount of cell falls off as the square of the distance. At the very center location where the food is located, those are both going to be 0, and I don't want to divide by 0 error, so I'm putting in a 1. So one way to think about this, where the food is located, this is 0, this is 0, so the whole denominator is 1, the scent range is 5, so the amount of scent where the food is located is exactly 5. And then we simply take that amount of scent and put that in the cell. But we've got to do 2 things to be a little bit careful. One, we've got to make sure that we're actually on the map, because it's possible if a piece of food is near the edge of the map, I've now wandered off the map and I don't want to do that. So I'll have to put in a check for that. And then we have to know whether we're putting down a fruit scent or a seaweed scent. So that's my check to make sure that my R and C values are within the grid, within the map. And then I check for what kind of food is located here. So we need to be a little bit careful. I'm checking row and column, which is where the food is located, to see if it's a piece of fruit that's there. And then I'm increasing the scent at the RC location, which is away from the food, by the amount of scent, let's fix that, times the flag. So when I call this function, I'm either going to pass it 1, which means increase the scent, or I'll pass it a -1, which means subtract the scent. And we need to subtract the scent when a piece of food gets eaten. And notice that I'm doing a plus equals. If we have two pieces of food very close together, the scent between them increases based on both of them. And so I have to be careful to do a plus equals and not just set it equal to a particular amount. And now that we've done it for the fruit, I can do the same thing for the seaweed. There we go. And that should be putting the scent in for the fruit if we call it. Let's see, scent seaweed and scent fruit. Let's look back at my cell. I named it the other way around, fruit scent and seaweed scent. So let's go back and switch those. So this will change it, but I have to be careful to actually call this function. So every time I add a piece of food by calling the add food function, I want to change the scent. So I'll come down here, and now that I have added a piece of food using this function, I will ask it to change the scent. So tell it the row and the column where the food's located, and a 1 to say increase the scent. And if I run this, nothing looks any different because I'm not displaying that scent. It's helpful to be able to see it just for debugging purposes. So I'll put in a little code to display the scent, but it's really not necessary. So this will display the scent for fruit. So we're going through the entire map. If there's any scent of fruit in a square, that is if it's larger than 0, then I want to fill with red, no blue or green, and then this last value is the transparency, so I'm going to make it fairly transparent. We've already said the level of scent goes from 5, where the fruit is, and then falls off fairly rapidly. So I'm going to multiply this by 20. Again, it was some fiddling to get that to be a good number. And then I'll just draw a rectangle. And this is the same thing that we were doing in the display, except now we're filling in that cell with color based on scent. And I'll just do the same thing for seaweed, except that in this case, I want it to be green, not red. And so this is my display function, and I see I did this exactly backwards again. That should be the fruit scent. And this, of course, should also be the seaweed scent. So let me double check. If the fruit scent is larger than 0, put down fruit scent. If the seaweed scent is larger than 0, make the transparency based on the seaweed scent. And I need to call this function, so I'll do that from my display. So after I've displayed everything else, let's come down and display the scents. If we zoom in a little bit, you can see we've got fruit with a range of scent around it that our creatures will be able to sense. We've got our seaweed with a range of scent around it that our creatures will be able to sense. And so there's our basic environment for our artificial life simulation. Clearly, there's lots that can be done with it. You can add different terrain types. So you could add mountains or deep water or grasslands just by going in and modifying the code. You can make it larger or smaller by changing those parameters, change up how it's colored, lots of different options. Again, if you want to sort of check some of them out, take a look at the video I have on generating maps. For now, I think we're in a good place. The next thing we need to do is add the creatures, but I'm going to save that for another video. Thank you.